Hi, everybody. My name is Felipe Huici. I'm the CEO and co-founder at Unikraft, and today I'm going to be talking to you about how to build cloud platforms that are 10 times more efficient, and in particularly something we call Craft Cloud, which is the cloud platform we've been building for the last year or so. So first, I've been asked to tell you a few things about me. Something cool I've done. Well, I'm building a millisecond cloud platform, and usually, hopefully, by the end of these 20 or so minutes, you'll understand why we call it that. My perspective on P99s is performance is fundamental. It's a lot of fun, and it's often very challenging. Another thing about me, I'm from Argentina. Yeah, but I've never met Messi, in case you're wondering. What do I do away from work? I do sports, guitar reading, and photography, although I don't get a whole lot of time away from work, but that's okay. Okay, so just to get started, imagine you want to put a workload on the cloud. Let's take Nginx, a web server, for example. And imagine we can just, one way to do it is go to the AWS Marketplace. Here's a standard image for it, and it gets deployed in a Ubuntu image. And if you do that and you add these up, you get a pretty massive image of 2.6 gigabytes. So what we're basically saying is if the application is Nginx and you know what it's going to be before you deploy it, and when you do cloud deployments, you almost always know what you're about to deploy, why don't we build an image that only has the functionality that Nginx, the application, actually needs and nothing more? And that's exactly what we do with Unicraft. And if you put those together, you end up with a much more reasonable 2 meg size image. Here's a few more numbers. On the left, we have Linux. On the right, we have Unicraft. These are Nginx images both running on EC2. And you can see that this sort of specialization affects a lot of metrics besides just the image size. So at the top level, you have actual boot time of the OS, which is 2 seconds for Linux and 6 milliseconds for Unicraft. Of course, you can tweak Linux, but this is orders of magnitude, right? Then the application boot time gets better. So this is the time between the OS booting and then the application booting itself. So all of it together. Memory usage goes down considerably, so it could be hundreds of megs for Linux and just a few for Unicraft. And then at the bottom, you see the image size I mentioned earlier. So how do we do this? In one word, specialization. So as I said before, if you have the application at the top, you have system libraries underneath, and you have the OS and the kernel, and there's a lot of components and everything goes into the image. Even though maybe only the colored segments are what the application actually needs to run. So it'd be nice if you could sort of automatically just gather only the colored parts and put it in a specialized image, which the technical term for a specialized VM is a unikernel. And Unicraft is both a modular OS and a build system to put those unikernels together quickly and easily. So Unicraft was born about 5 years ago as a Linux Foundation open source project, where we were thinking that the way things get deployed in the cloud weren't necessarily super efficient. So we had these three main principles. The first one is we knew we wanted to be fully specialized to get all these nice numbers I showed you. And in order to do that, we needed the OS to be fully modular. Everything in Unicraft is a library. Everything you can sort of easily take in and take out, depending on what the application needs. And I'll show you a little bit about the architecture later on. The second principle was Linux API compatibility. We didn't want to force people to have to modify the programming language, the application, whatever, to comply with Unicraft, because that was never really going to work. We also didn't want to be a one-trick pony where we could only run a single programming language or application. Basically, if it runs on Linux, it runs on Unicraft. The third principle is tooling integration. There's lots of amazing tools out there like Docker and Kubernetes. And while we provide our own native tool called Craft, we do a lot of work so that Craft integrates with higher level tools like Docker and Kubernetes. Okay, so first a little bit about the Unicraft architecture. So at the top level, we have the application, and right under that, we have the libc layer. I mentioned that Unicraft is all library based, so we have both the choice of Muscle and newlib. Newlib is a libc from the embedded world. Muscle is a glibc compatible libc. So you can pick and choose out of those. Below that, we have the POSIX compatibility layer, which provides things like pthreads and sockets. All of this is optional. So if for some reason the application doesn't need this layer, it can be fully removed. And then underneath, you have the typical OS primitive layers to do with network stacks, which are again swappable, schedulers, memory allocators, all of it swappable. Under that, we have the platform layer. So you can have, in this case, so far we support KVM and Zen, although there's OSS work being upstream to support VMware and Hyper-V. And then in terms of CPU architectures, we support x86 and ARM64. And again, on the OSS track, there are patches for RISC-V support. Okay, so that's for the basis. And now I'm sort of switching a page and going to Craft Cloud, which we call the millisecond cloud platform. So this is a cloud platform that we've been building. It's in beta right now, closed beta, and it leverages all the properties of Unicraft that I just sort of listed. So first, a little bit of a Craft Cloud architecture. This is what a single server typically looks like. So we have a bare metal server with a Linux host running KVM on top. And we use FireCracker as the VMM with some modifications. And we have a user space process that manages and controls the platform and exposes a REST API with which our users interact. In addition to that, we have an image registry. All the Unicraft images that people build, which you can build on your own or we can provide them, get put on the registry, and then the platform gets those from the registry to actually run. And then, of course, on top of that, you have the actual virtual machines or guests. Here I'm showing some Nginx ones, some SQLite ones, and so forth. Okay, so we think Craft Cloud has a number of differentiators with respect to standard cloud platforms from hyperscalers and the sort. The first one is that we can scale to zero. So if you're idle, we can shut you down so that you don't have to spend any money for idleness. And not only scale to zero, but do it in windows of tens of milliseconds even, because we can bring things down and bring things up very quickly. We can offer a much lower price point because, as I'll show, we can put a lot of instances on a single server, a lot more than other providers can do. We can deploy a lot of edge locations. I already spoken about the small images that we can have. We have something called what we call death to cold boots. This is basically our cold boot times, and I'll show them later, are pretty short. So even though they're technically still cold boots, they'll sort of hopefully unnoticeable to the end user, to the users of our platform. Another property that is derived from these quick boot times is immediate autoscale. This means that we can start additional instances to cope with peaks in again, timescales of just milliseconds. All of this happens with full hardware isolation, and then the guests themselves provide a secure minimal TCP that arises largely from specialization at compile time. And then finally, we can do all of this with a reduced carbon footprint because we require fewer servers to run equivalent workloads. Okay, so that's the theory. Craft in practice, as I mentioned, we're in closed beta, so you can go and sign up for free at craft.cloud. You receive an account and a token, and then you can follow documentation on docs.craft.cloud. And to interact with the platform, this is obviously in the documentation, but the rawest form is there's a REST API, and you can sort of send curl commands. Craft is the Unicraft native tool. You can use that to interact with the platform. And then we're working on Docker and Kubernetes integrations. To communicate with us, we basically have two Discord servers. On the Linux Foundation OSS side, if you go to unicraft.org, you'll see a link there. So we're always super happy for people to join. I think we have hopefully a friendly community. And then on the Craft Cloud side, once you get your name and token, we give you information and an invite to a Discord server where you can get tech support. Okay, so that's for sort of the basics and maybe the boring part. Here's for the fun part, especially for P99, the performance measurements. And before I get started, just a little note that we're using a server with 24 cores and 64 gigs of memory. And unless I otherwise say that the specs are different, these are what they are for most of the experiments. Okay, so this is the very first graph, which is about cold boot times. We're using Nginx as an image, but it could have been something else. On the x-axis, we have the number of running instances, and on the y-axis, the boot time. The way we set this up is we boot an instance, we measure the boot time, we leave it running, we start the second instance, we measure the boot time, we leave those two running, and then the third one, and so forth, all the way up to 5,000. And when you do that, you can see relatively low times of about 4 milliseconds for the first instance, but still relatively low times of 14 milliseconds for the last VM, the 5,000th VM. So overall, relatively low. And these are cold boot times, right? So this is as bad as it gets. This is a chart also of cold boot times, here comparing it against Linux and showing a few different applications. So not just Nginx, but also Redis, SQLite, Node.js, and a Go-based HTTP server. Mostly you can see that there's orders of magnitude difference between Unicraft and Linux. Maybe you can notice that Node.js is a bit longer, 47 milliseconds. Obviously, it's much bigger, requires more memory, takes more time to set up, but we're constantly improving on these times. In terms of security, I briefly mentioned that we have good TCB reduction, so the size of the image gets reduced, lines of code, and so forth. This is a little measurement for it. Again, taking Nginx as an example, we have Linux on the first column, Unicraft on the right. And for image size, just for the Linux kernel, you have 30 megabytes and the application, and then Unicraft is about 2 megs or about 1.25 megs if you enable DCE. In terms of the lines of code, again, the kernel plus the application, this is about 5.5 million for Linux and about 280,000 for Unicraft. And on the number of symbols, again, you get a couple of orders of magnitude reduction going from Linux to Unicraft. Okay, so this is a P99 conference, so it's almost mandatory to have some sort of P99 graph, and here it is. So this is a graph of Unikraft latency going up to about 5 nines. The different lines are latency when running 1,000 VMs, when running 2,000 VMs, and when running 5,000 VMs, but you can see they're pretty much on top of each other. And in the worst case, we have a relatively low latency of just under 1.5 milliseconds. Okay, then a graph about throughput. In this case, Unikraft again versus Linux and Nginx. I need to point out that what we're doing here is using WRK to generate the HTTP traffic. We're varying the request size on the x-axis, going from a relatively very small 16-byte request size all the way up to much larger ones. And you can see in the graph, Linux in red is performing at about 35,000 requests per second, and Unicraft almost at 100,000, so quite a bit higher. Eventually, as you go to much larger request sizes, these things tend to converge. That's normal because the overhead from actually handling each of the different requests gets very small, and so then basically Unicraft and Linux perform equally. Okay, so this is max density. So this was basically us stress testing one of our servers to see how many of these instances could we stuff, as many as possible, into this single server. For this test, the server is different. You'll notice at the bottom that mostly the main difference is that it has 1 terabyte of memory. So quite a bit more memory to run the test. And again, as before, on the x-axis, we start one VM, we measure boot time, and then the second one, except this time we go all the way up to 90,000 VMs. And of course, the boot time shoot up, even though it's still under 1 second for the worst one. But you can see that it's kind of nice to see a stress test where you have 90,000 VMs running on a single server. Of course, in production, we wouldn't push it to this limit. We wouldn't run these many, but it's orders of magnitude. So you can see we can fit quite a few more than you would with regular images. Okay, and then memory consumption. Maybe let's just focus on the blue line. The blue line is tracking per VM memory consumption for the guest and how much memory the host needs, the VMM and so forth, to support that guest. And you can see pretty much it kind of tracks linearly. On the rightmost extreme, we have again 5,000 VMs. That's sort of mapping to about 50 gigabytes of memory, which is reasonable for a modern day server. And this is just to show that it's also the relatively low memory consumption of our images that allows us also to get to these sort of densities. Okay, then in terms of image sizes, in this case, we just picked a sample few applications, Nginx, Redis, SQLite. We're comparing against the equivalent Docker container and then Unicraft on the right-hand side. And you can see there's roughly an order of magnitude difference, about 30 megs for Nginx on Docker, 3 megs on Unicraft, 37 on Redis megabytes for Docker, and 2.8 for Unicraft. And SQLite about 26 megs versus 3 on Unicraft. Okay, so it's demo time. I'll do a few brief demos. The first one, I'll start the video. We're going to be using the Craft native tool. First, we're going to be doing a Python server. Okay, there it is. We copied and pasted the code, and now we're going to run Craft Cloud deploy, and we're going to point it to the directory. Craft is going to figure out that it's a Python script. It's going to build a Python image. So it's going to build it first. It's going to package it as an OCI archive. It's going to push it to the registry I mentioned during the architecture. And then when it's done, it's going to immediately boot it. Okay, and then for the other video, this is for Nginx and HTML. Basically, we're going to edit an HTML file, so you can see that we're doing this for real. We're going to curl it at the end. Okay, there it is. And just as before, we're just going to point Craft at that directory. It's going to figure out that it's HTML. It's going to default to Nginx. It also has some defaults as to how much memory to use and so forth. It's going to build it again, package it into an OCI, push it to the registry, and then immediately execute it. And when it's done, you can see it's booted. I think it says boot time 8 milliseconds. There's a DNS name given where the service is immediately available. And if we curl it once again, you just sort of get the output. So that's a very basic workflow. And of course, the documentation on the platform has more advanced ones. Okay, so that's most of the content. Please do go to craft.cloud, and some of this stuff resonates, or you'd love to tinker with the platform. As I mentioned, we are in closed beta, so it's free for use. So you just click that blue button, and then you get to this form. We try to keep the form as brief and short as possible and painless as possible. So you fill that out, and then basically we're sort of doing onboarding of users in batches. So I hope you do drop by. And then finally, we're always looking to get contact and feedback from users. Either Discord OSS or my email address is there, my Twitter handle, or simply just go to the websites. Any sort of feedback, positive, negative, we're more than happy to hear. And I hope to see you in a unikernel-based cloud platform sometime soon.